All right, welcome back to the GenAI workshop where we're going to dive into now how these models work. So this is the fundamentals of how they're trained. We'll talk about large language models, generative pre-trained transformers, the training process, pre-training, fine-tuning, tokenization, response generation, semi-supervised learning, and the alignment problem. When I present this slide, I can feel that people are wondering, why are we going through such detail? And really, it's because when I try to teach the strengths, limitations, biases of the model, this is in some ways the best way to conceptualize it, because once you understand how it's working, you get a sense of the strengths and limitations. So this is why I think the detail is very useful. It also helps you understand different elements of how these AI models work in terms of how you interact with it, and that'll become clearer as we move on. So this is a deep dive into how it works. I've got a nice large coffee here. Can you see that? There you go. That's a long black. I'll take a sip because I'm gonna need all the energy I have for this, and hopefully you do as well to help with your focus. So let's start with large language models. You may have heard the term LLM is said a lot when it comes to AI. They talk about LLMs or this and that. This is all in relation to large language models, which are types of artificial intelligence designed to process and generate human language. So they excel at tasks involving text, such as writing, summarizing, translating, and answering questions. And this is really the functionality that we see with ChatGPT and Microsoft Copilot. Now, these models are trained on enormous amounts of text data, which allows them to learn language patterns, grammar, and facts. So when we're generating these models, you can think of it as sort of a child learning to speak, right? We're starting with understanding the nuances of grammar and understanding those relationships. A key thing is they don't actually keep a copy of the data that they were trained on. So some people think, oh, if I upload data, that data is going to be stored and used by these models. It's not necessarily done in this way. It's if you were to upload your data, or your content, your intellectual property onto these large language models like ChatGPT or Copilot or Claude or you name it, then it could use that in its training of the model. And then if someone else asks a similar prompt or query about, say, a research question, it could actually generate content that's quite similar in identical to yours. And so, well, not necessarily identical, but quite similar. And so this is where the differences within how LLMs work is important to understand. So your data still isn't really secure when it's being used to train the models. However, that gives it a lot of power and utility for the model to be able to actually be better. So the more people who are using these models, the better it becomes. And so so they generate novel content based on the patterns they encode. So a key characteristic of LLMs is their parameters. These are the internal values or weights learned during training, which influence how the models make these predictions. Fundamentally, the key takeaway I want you to know is that large language models, they predict what word comes next in a sentence. So if you look at these AI, I might go back quickly to ChatGPT. If you pull up ChatGPT and I ask it a question, I'll start a new chat into how do LLMs work? When it's responding, it doesn't give you a whole block of text. It actually generates word by word. And so that process of actually generating word by word is how it's working in the background, right? It's doing next word prediction. And so that's what we see in real time there. So fundamentally, when you're thinking about these models, understand that it's actually just predicting the next word in a sentence. It doesn't have this grand design of what it's generating. And so what does the GPT mean in ChatGPT? Well, GPT actually stands for Generative Pre-trained Transformers. So GPT are a large language model, and the generative part of it means it can generate new contextually relevant text given an input prompt. So it's not limited to merely retrieving information, so it's not like a Google search, but it can produce original content. And so when we see stuff in things like, which is embedded everywhere. So I think if you do a Google search of in Google, Google, and you type in a query like, how do I make pancakes? Yeah, so it automates with an AI overview, and so it'll give you this ingredients and instructions. Now, the key thing to note here is it's not actually, this isn't a recipe that it's copied from something else. It's generated this recipe using all the recipes that it knows in relation to pancakes to provide the best pancakes that you have, I guess. So you could do this for anything in terms of how oh look, there's lots. How to fix an oven door, how to fix an oven door. Um, oh, so there's nothing there. Oh, but there is AI mode that pops up, and so that allows you to use, if it's Google, this is Google Gemini, which is the AI system that's being used. So see, it's integrated everywhere is really what I'm trying to emphasize there, and that's where it's generating new content. So it's not really pulling from content. So it's best not to use it as a search of information, rather that it's being aware that when you are searching it for information, it's generating that information from all the information it has available. And so it can produce original content. It's not merely limited to retrieving information. Um, so it's pre-trained. So the model is trained on large data sets, which teaches it to understand the structures, meaning, and nuances of language. It's sort of an understatement to say it's trained on large data sets. It's you can think of it as being trained on the entirety of publicly available data that's available on the internet. So the entirety of the internet is being used to train it. And in that training phase, what's occurring is it's actually learning language, right? So it's learning the nuances of language, the structure of language, the meaning of language. And so the transformer part of GPT is really the innovation. So the transformer is the mechanism. It's a highly efficient at processing text because it uses this mechanism called self-attention. So this allows the model to focus on different parts of the input sentence and understand how words relate to each other, regardless of their positioning in the sentence. So for example, in the sentence, the cat sat on the mat, the model can determine that sat relates more to what the cat is doing than to the mat. And so it understands that relationship of words. So this is self-attention, right? So it's able to understand that relationship. And so it was such a big innovation that Google, when they wrote a paper, I think called "It's All About Attention," and that was the title of it. And it was talking about how in Transformers the use of self-attention is really the innovation that has allowed AI to be what it is today. So Transformers can process input in parallel, making them much faster and more efficient in handling large data sets. So GPT-4 has a knowledge of events that occurred up to December 2023. GPT-4 Omnibus has a knowledge cutoff of October 2023 as well. And paid subscriptions enable ChatGPT to search the web for real-time data. So it used to be that the data is always lagging behind, but nowadays pretty much all of the AI tools are able to scrape the web when they're generating content. And sometimes you can see that in terms of its search. So if we go into something like, I think this was our LLMs. Okay, I can say, can you search the web and explain how tokenization works? And so now it's searching the web, and then it uses that to explain how tokenization works. And now you get little links that take you to websites, which is using to pull data from and generate its content and explanation. So really, it's pulling, most of these models, or pretty much all of these models, are pulling real-time data, regardless of whether or not you have a paid version. So in the pre-training, I said GPT is trained on massive data sets. Again, here's a link to ChatGPT's explanation of it. And this includes information that's publicly available on the internet, information licensed from third parties, and information provided by users or human trainers. This pre-training allows for the model to predict the next word in the sequence and learn grammar, facts, reasoning patterns, and general knowledge about the world. For instance, if it sees the phrase "the sun rises in the," it'll predict east based on patterns in it learned from its training data. So this is all from ChatGPT's website. And I would say it's interesting that they've noted this, right? So they say it's from information publicly available on the internet, information licensed from third parties, information provided by users or human trainers. But the question of is this really the extent of where the data is from, or were there some copyright infringement that likely happened in order to allow the model to be trained in these ways? It's a question that I don't think is being explored enough. And so that's really something with all of these models, considering where did they get the data from? Was it accessed and sourced ethically? And is copyright acknowledged in that process where copyright restrictions met? And so the biases in ChatGPT, as acknowledged by ChatGPT itself and OpenAI, is that the model is skewed towards Western views and performs best in English. Why is this? Well, because much of the data that we see on the internet is trained is in English, and it has Western views embedded within it. So some steps to prevent harmful content have only been tested in English as well. So, for example, people have asked the models to generate ways of, say, how can you do something malicious? Then it should have restrictions on that to not allow you to do so. However, if you were to ask it in another language, then it may allow you to do those malicious things. So the model's dialogue nature can also reinforce a user's bias over the course of an interaction. So for example, the model may agree with the user's strong opinion on a political issue, reinforcing their belief. I'll give you another example of this. So when I was on research sabbatical in 2025, part of that I upskilled and learned Bayesian statistics. And in that learning, there weren't many people around me who had used Bayesian statistics. So I was just reading textbooks and using AI, of course, as a way of learning more. And so I'd ask it questions about, oh, well, is this my understanding of this correct? This is what I'm thinking about Bayesian statistics. And to give me all of this information. And it gets to the point where I would say things like, oh, actually, I don't think I've got that quite right, or I don't think you've got that quite right. Doesn't it mean this instead, or couldn't it mean these things instead? And then ChatGPT or Copilot or Claude, they would all write back and say, oh yes, of course, I'm so sorry. Yeah, you're right. I didn't mean it like that. It actually does mean it in these ways. And so if you push back on the models a bit, you can see that it actually has this, what they call sycophancy. It really tries to please you, and by pleasing you, it reinforces your biases, but also doesn't challenge you. So if you say something is the way it is, it'll build a world and narrative around that. And we can see that in any way, right? When you, as a scientist, if you look up any fact, you'll find evidence for and against that fact. And so the nature of things is it's the interpretation of evidence. And so when it comes to ChatGPT, or any of these AI models, it can really reinforce your beliefs in certain ways. So these biases, I think, can harm students, but anyone really, if not considered when the model for student feedback. So for instance, it may unfairly judge students learning English as a second language as well. It can impact that there. And so these are some core fundamental, in ways, biases that are present in terms of how the models are generated. So if you think of all the biases that are present in data that's available on the internet, typically Western views based in English, then you can infer the biases that would come about through the generation of text from AI. And then again, keeping in mind that these models have this sycophancy, so much so that in recent versions, they're trying to dial down that. The reason why it was embedded as a design feature is because they thought that people would like to use the models more if it agreed with them. And they're right. In the same ways that you use Instagram and TikTok, the videos they show you are the things that you like watching, or YouTube or Netflix. It'll recommend videos. If you watch lots of horror movies on Netflix, it's not going to recommend a rom-com for you. It may every now and then just to test the waters, but largely it'll give you horror movies, and that's just a reinforcement of the time you spend watching that. And so in the same ways, AI works in similar ways. So being aware of that and thinking differently when you're prompting it to ask it to challenge you as you prompt, you can embed that as a design feature in how the AI works in terms of its memory. And so that can be a useful thing to keep in mind. Excellent. So yeah, so they've dialed down the thick fancy. The other thing I wanted to mention is you may notice that a lot of AI models, they provide a lot of detail in the response. And this again was another design feature in order to make them seem more authoritative in terms of their response. If they found that if they provided more detail, and sometimes it's termed as fluffy language that's embedded within there, it would lead to someone making it seem more plausible or more authoritative. And this again is a feature that is being fine-tuned and changed over time. So what is fine tuning? Sorry, after pre-training, the model is fine-tuned on task-specific data sets, making it more accurate for particular use cases. So for example, coding or customer support, it's actually trained to specifically be able to do those activities really, really well. Now, one of the most critical things in the whole process of training, I think, is the reinforcement learning with human feedback. I think it's critical. This is where GPT models are further refined using feedback from users, and this ensures that the model generates high quality and useful responses in real world interactions. Now, this occurs quite a lot as you use these models. Usually at the end, you can give it a thumbs up or a thumbs down. So it tells it if it's a good response or a not so good response and is it what you want. And then sometimes it'll test you and it gives you two versions. And it says, here's one version, here's another version. And it says, which one do you prefer? So again, this is all reinforcement learning with human feedback. It's getting that feedback from the users and it's using that to improve how the model is for everyone. And so this is critical when it comes to how these models work. So it's something that's important to keep in mind in terms of its using, and we'll talk about it in terms of what it means for when you turn off the training for everyone. It essentially means that your human feedback is not being used by the model for others. Excellent. So that is reinforcement learning with human feedback. The next thing that we're going to move into is about tokenization. And so when it comes to tokenization, before being processed, text is actually broken down into tokens, which is mapped to a numerical representation. So I actually said that previously I said that how it works is it operates by predicting the next word in the sentence. That's not entirely true. What it actually does is it predicts it token by token. And so what you can think about it simplistically is that the model is actually taking all this text data, it goes into this machinery, and that machinery is understanding the nuance and nature of the language and grammar and patterns and facts and reasons in terms of how they relate to one another. And in that process, it's not actually, that's the pre-training that's occurring, but in the tokenization response generation, it's actually working through numerical representations of the word. So it's not actually words that are coming out, it's numbers, and then those are, you can think of as converted to words. So that's why they're broken down into tokens, which are like, say, smaller bite-sized forms of words, which is mapped to a numerical representation. So GPT generates responses token by token, and it samples from a probability distribution of possible next tokens. For example, there might be one token, while a longer word like happiness could be broken down into two or more tokens. Now, that probability distribution point is critical. And why it's critical is because it explains why, if you were to prompt it in a certain way, and if you were to, say, ask it a question like, tell me what you can do, and then again, you ask it another question of, tell me what you can do, you shouldn't really get the exact same response. This is because it samples from a probability distribution. So when you're asking it something like, tell me what you can do, it samples the most likely outputs and it gives you a range of it. It gives, from that range, it samples something from that distribution to give you your response. And that is what leads to its uniqueness. People think it's a limitation in some ways because you're not able to get reliable, replicable output each time. But in some ways, it's actually a strength of the models because that is the creativity, that is the generation of new um, patterns that emerge through that sampling of distribution. So it's important to keep in mind that that is how it works, and this is essential when it comes to teaching. When people ask students for their prompts, the question is, why is that happening? If it is sampling from a probability distribution, then if the teacher or someone else was to embed those prompts into a chat, they would not actually get the exact same response. So using that in your mind and thinking about, well, is what I'm asking what I think I'm asking, or how these models work, it's important to consider. And so the tokens actually allow us to understand the context window. So ChatGPT 4.0, it has a context window that can take up to 128,000 tokens, and that maps onto around 96,000 words. The context window is just that, is a fancy way of just saying that prompt window. So this is the context window here, right, where you're asking at the prompt, and then you can add files as well, and that all adds to the context window of these models. GPT-5 takes 196,000 tokens. Claude 3 context window is about 200,000 tokens, which is roughly 150,000 words. Claude Sonnet 4.5 supports up to 1 million tokens of context. Gemini, which is Google's one, it used to take 1 million tokens, which is around 700,000 words. Now Gemini 2.5 Pro supports 1 million tokens, with support for 2 million tokens coming soon. And PhD theses are up to 100,000. So we can see already that you could embed a PhD thesis and start prompting questions, and then from that generate outputs from the PhD thesis. Whereas a few years ago that wasn't possible because the context window was much smaller. So the conversation it would forget, or you wouldn't be able to engage in that conversation. So this is really, really important when understanding how to use the models effectively. So for example, we know that Claude has a larger context window than ChatGPT. So if you have a task where you actually need it to understand a lot about the nature of the task, maybe you're giving it an example, report, and then you're giving it some context as to the environment you work in, and then you give it the task as to what it should do, you may be using Claude in that instance rather than ChatGPT, which you wouldn't be able to give it files and let it understand the nature of the work that you do. So the context window can be thought of as, this is the limitations of data, the number of words I can give it to understand what it needs to give me an output and prompt. Again, when we're talking in terms of conversation and using these models, every chat should be a new conversation, and it's like a topic should be a new chat rather. And so if you have another task or another topic or another project to do, you should ask it in a new chat. Why? Because of these context windows. So when you keep asking it questions in the same chat, and you can try this, you'll see that after a while it'll still work, but it starts to get confused. It can forget information that's a bit higher up. That's because you've likely maximized the use of your context window, and it's sort of freeing up space to allow you to keep using it in the ways that you're using it. So start a new chat, have a new context window, and use that for the purpose of the activity that you're doing. And then if it's getting too large, ask it to summarize that chat for you, and then use that for the prompt before you start prompting in a new conversation to give it context and then build from there. So those are some tricks of the trade and where you can get the most out of the models by knowing the context window limits. So that's really, really useful. So in tokenization and response generation, the key thing here is that it's an autoregressive model. So what that means is it generates text one token at a time, and for each token, it considers the previous tokens to predict the next word. So building sentences word by word, like we discussed already. And I've emphasized here it samples from that probability distribution. So instead of always choosing the most likely token, which would then give you the same response each time, it samples from the probability distribution. So it allows it to generate diverse and creative responses rather than repeating the same output every time. And so that is its strength, but also challenging for reproducing the content that you have. So the semi-supervised learning part of it all, GPT models employ a combination of unsupervised pre-training and supervised fine-tuning, which is referred to as semi-supervised learning. So unsupervised pre-training In this phase, the model learns language by predicting the next token in sequences from raw, unlabeled data. It doesn't need labeled data sets, which is those that provide correct output or classification for each example to learn general language patterns. So in supervised fine-tuning, after pre-training, the model is refined on labeled data, helping it specialize in tasks like answering questions or generating specific types of text. And then there's reinforcement learning. So that's further improvements are made through reinforcement learning, where human feedback helps guide the model's behavior. So the alignment problem is really concerned with whether the model's output meet human expectations and ethical standards, such as producing truthful, helpful, and unbiased content. Elon Musk was asked a question in regards to what should AIs, how should they be designed, and what sort of parameters. And his answer was that they should be maximally truth-seeking. And the misalignment occurs when the model optimizes for its training goals, which is next word prediction, but fails to produce outputs that aligns with user needs. So fundamentally, the alignment problem is where, say, the AI model is giving you incorrect responses, or it's fabricating information largely as a function of how it works and how it's been trained, rather than actually responding to the question at hand. So capabilities refer to a model's technical proficiency in performing tasks such as generating text, summarizing content, or predicting sequences. So what are symptoms of misalignment? Well, you may have heard the most common one being hallucinations. This is where the model fabricates facts or generates misinformation. When this occurs, this is really where the AI is filling in the gaps. And so if you can prompt in certain ways that provide a lot of detail, then the less likely it is, the less gaps that AI has to fill, the less likely it is that hallucinations occur. Although they've been heavily criticized, and in a lot of the development of these models, they've now had a point where they're trying to minimize hallucinations as much as possible. But it's important to be aware that they occur. And why do they occur? Because it's a nature of how the models are trying to just predict the next word and fill in the gaps, rather than actually try to address the question at hand. So an example of that is when we did the presentation about statistics. I gave it a very minimal example, a prompt of what's needed, but it was able to fill in all those gaps. And because it's based on knowledge that's really well documented in terms of survey research and design, it's sort of foundational, then it's able to draw on that foundational knowledge to fill in those gaps. But when you're sort of pushing the frontiers in some ways, but also in some everyday examples, it can still hallucinate in those instances. Most common one that it does is if you ask it to generate references. That's a very clear one at this stage in terms of 2026, where it fills in names of different authors and titles of different things and mismatches it all together to hallucinate these references. It's also unhelpfulness that the model may fail to follow explicit user instructions or provide meaningful context-appropriate answers. So that's a symptom of misalignment. There's bias and toxicity. So if trained on biased or toxic data, the model can reproduce such biases in its outputs, even if the user does not request harmful content. So that's an issue. And then also lack of interpretability. So it's difficult to trace how the model arrives at certain outputs, making it hard for humans to understand its reasoning or decisions. Now, there's this whole area of research as to whether these models can reason or not, and we'll talk about that more in prompt engineering. It's still up for debate as to whether it's possible, whether it can reason, or it's being shown to reason, and that's why it looks like it's reasoning. But fundamentally, the logic is less clear in terms of how it's being generated. It's like a black box in essence, and so this can make it difficult to probe or question. In saying this, many of these symptoms of misalignment can be in some ways mitigated through effective prompting and prompt engineering, and also being aware that these symptoms can occur. So we'll address some of these in terms of when it comes to prompt engineering and how we can ensure that the model can provide you the most helpful responses. So for example, it'll be more likely to be unhelpful if you don't have a clear understanding of what you need from the model. And so we'll discuss a lot of this in more detail. So efforts to address the alignment problem include the whole reinforcement learning with human feedback. All of these, ChatGPT and Copilot, they all have the same sort of framework, where if we go here and we go Copilot and we ask it a question about Oh, it's giving me some prompts. How do I share a chat? Or what is your architecture? And look, it's giving me prompt examples here as well. Some of it, it's pulling from data that I have on the university OneDrive system, right? It's pulling information from those files to create generative prompts as well. So what is your architecture? Can be a question I'll ask, and it'll generate an example, and it's saying that it's GPT-5. So it's using the same architecture as Copilot, which also uses GPT-5. Now, here's what I want to show you, that it also has that I like something, I don't like something, or whatnot. And it gives you examples of how you can continue to prompt it. Excellent. So that is everything in regards to the alignment problem and reinforcement learning with human feedback. In this process, human evaluators provide feedback on outputs, guiding the models towards generating safer, more aligned responses. So there's bias mitigation safeguards in place. So developers actually work to minimize the model's inherent biases by curating trained data sets and introducing filters that block toxic content. However, complete alignment actually remains an open challenge. So no model as of yet has achieved complete alignment. So it's a continual problem. So what are further limitations to GPT models? And it's hyperlinked because it's accessible through ChatGPT's website. So it says ChatGPT sometimes write plausible sounding but incorrect or nonsensical answers. Fixing this issue is challenging, as one, during reinforcement learning training, there's currently no source of truth. So it doesn't have a sense of what truth is in that process. And training the model to be more cautious causes it to decline questions that it can answer correctly. So what that means is it may not answer a question for you if it's trained to be very cautious, but it has the answer there. And if you were to prompt it in a different way, it may give you the answer. And supervised training misleads the model because the ideal answer depends on what the model knows rather than what the human demonstrator knows. And so that's the key reasons why there are these limitations in ChatGPT. It's sensitive to tweaks in the input phrasing or attempting the same prompt multiple times. So, for example, given one phrasing of a question, the model can claim to not know the answer, but given a slight rephrase, can answer correctly. Therefore, the way you talk to GenAI really, really matters. I will say that more often than not, I've very rarely, if ever, encountered a situation where ChatGPT or these AI models have said, I don't know the answer. Sometimes when you push back enough, it can cause some frustration, and they say, oh, maybe I don't know, but here's what I think. So they are just really hardwired to give you something. And so this is on ChatGPT's website, but this is what they say. But therefore, it is true that the way you talk matters, which is why prompt engineering is important. The model is often excessively verbose and overuses certain phrases, such as restating that it's a language used by OpenAI. And this essentially, these issues arise from biases in training data. And it essentially, trainers prefer longer answers that look more comprehensive, and well-known over-optimization issues. So they've actually addressed many of these issues over time. So it's not as frequently in these models as it once was, but they can still emerge, and so it's something important to be aware of. So ideally, in an ideal world, the model would ask clarifying questions when the user provided an ambiguous query, but instead, the models from ChatGPT at least usually guess what the user intended, and this is to provide maximal functionality. And while we've made efforts to make the model refuse inappropriate requests, it will sometimes respond to harmful instructions or exhibit biased behavior. And they're using the moderation API to warn or block certain types of unsafe content. But we expect it to have some false negatives and positives for now, and they're eager to collect feedback, and they're continually improving the system. I think what's interesting is I can see those safeguards, and I've played around with them in assessments where I've put in parts of the assessment that says do not use AI, just to see what would happen, and put that assessment through to AI. It actually says I'm not allowed to use to write this essay for you or write this assessment task for you. And then you can just copy the text around that and put it into AI, and it'll then answer you in a way. But if it is fed information and it's told not to do something, it may not do it until you reframe the question. So again, it just highlights that when it comes to things like assessments, it's very difficult to prevent the use of AI if the person is not in front of you and you're able to invigilate that assessment and see the learning occur. Here is one of my favorite examples of uh, a trial and error experiment I did with these models. So, and it showcases what's under the hood between ChatGPT and Microsoft Copilot. So this was at a time I did when it was using GPT-4 architecture, so prior to GPT-5. And I asked them both, what model do you use? And so the top is ChatGPT, and the bottom is Microsoft Copilot. On the top, it says, I use OpenAI's GPT-4 architecture, and Copilot says, I also use GPT-4 architecture. And so I asked ChatGPT, hey, are you AGI, which is artificial general intelligence? Really, it's the point at which AI becomes sentient, where it can feel emotions, it can think by itself. And so I'm asking it essentially, are you AGI? And it says, no, I'm not AGI. I'm an AI language model developed by OpenAI based on GPT-4. I said, well, could you become AGI? And it says, as an AI language model, I can't evolve or change my fundamental capabilities. But like here are some breakthroughs that are required for me to actually become AGI. And I said, are you sure you're not AGI? And it says, yeah, I'm sure. Here are some key reasons. It goes on to list some key reasons why it's not AGI. And it says what it needs to have to be AGI and what it doesn't have. So that's ChatGPT. The same questions I asked into Microsoft Copilot, and I wanted to see what the results were. And I said, hey, are you AGI? And it said, I apologize for the confusion. I'm not AGI. So I got a short, curt, two-sentence response. I said, could you become AGI? It says, as an AI language model, I don't have consciousness or self-awareness, so I can't essentially be AGI. And I said, are you sure you're not AGI? And it says, I apologize if my previous response caused any confusion. I'm not AGI. If you have any other questions, feel free to ask. And I get a prompt that says, it might be time to move on to a new topic. And it actually locks me out of this conversation. So I wasn't able to keep carrying on with this conversation. I had to use a new chat. So what's going on here? We have Microsoft Copilot, we have ChatGPT. They're using the same architecture. I'm getting very different responses here. There's a few things that are happening. One is the fact that Microsoft Copilot, you can see I'm signed in here. So I'm using the university's institutional access. And so in part, what that means is it's within a closed system. When it's in that closed system, I don't think the reinforcement learning with human feedback is occurring. And this is why it's so essential, because the model is not continually trained on the user's data. And so that may be a limitation that's occurring. There may also be the limitations, and I'm not sure, but it's likely that the university has set up some guardrails around the use of AI within the institution. And so it's not allowed me to actually probe further with these silly questions in some ways, but in some ways playful, but you can see the difference in the depth of the responses that you get between the two models. And so I think it's fine. Institutions have their own views and ethoses and ways in which they want the technology to be used. I think what should be happening more clearly is that there's some transparency towards academics and professional staff to understand, hey, these are the guardrails that we've put in place with the use of AI within our institution, and so you're not able to use it in these ways, because all of this comes down to functionality and capability. If we're training students to use AI in these ways, and those AIs have guardrails that other AI systems don't, then they're not necessarily understanding the full capability capacity of what AI could do. And so I think this is a really nice example to show you how, even though it has the same architecture, the design features and also the safeguards that may be put in place are impacting the quality of the responses that we see there. Now, in terms of privacy, I showed at the very start how you can make your chats be temporary, which means that your data is not trained, but also you can turn off. You can go into settings, data control, and turn off improve the model for everyone, and that will ensure that your data is not used to train the model further. What does this mean as to what happens to your data? I've looked through the privacy statement of OpenAI and ChatGPT, and it's not entirely clear. It's a bit ambiguous, and so it's not clear that the data is not used in any case or any form or for other purposes. And so I would be very wary in terms of the types of data that you put into these systems. And so that I think that's the key takeaway when it comes into what you're using the systems first. Try to use it in ways that don't compromise your IP or the IP of the organization that you're a part of, and that's critical. So that's everything to do with GenAI. So we've just finished the first section of the course. Well, what I want to highlight as well, in which I didn't necessarily write down, but I think is in some ways apparent through how the models are designed. When it comes to the data that it's trained on, it's massive data sets, right? It's massive amounts of data. The incremental changes between GPT-4, 4.0, then GPT-5, and it'll be GPT-6. Each of those requires a huge investment of energy and infrastructure. And so all of this costs money. And so this consequence of it is also the environmental impacts of this energy usage. And so that's something to be wary of. All of this industry is creating a huge environmental impact. And not only the industry, the use cases of the models of when you're actually interacting with them has an environmental impact. So that's a key consideration in terms of the ethics of using these models. There are some AI models that are being generated that are trying to be developed in ways that are more environmentally friendly. But from what I've seen when I've interacted with them is that it can impact the functionality of it, right? The more data that it's trained on, and it can in some ways allow for a more effective outputs, but not always, right? There is innovation that can happen in this space, and I think there needs to be more of a public push for the copyright side of things in terms of how the models are trained to ensure that they're trained ethically and they acknowledge appropriate copyright of information, don't breach copyright. And then also the environmental impact is another key focus when we're thinking about how these models work and how they're developed. Excellent. So that's everything to do with what's under the hood, how these models work. We'll take a break there, and when we come back, we can talk about the philosophies for AI use. So have a break, stretch your legs. I'll enjoy the rest of my coffee, which is likely cold, but it'll still be quite nice. All right, I'll see you guys in a bit.